Whenever we take the data as a sequence of bits, and if we try to manipulate the data at the bit level, for example, incrementing a number is not actually working only on a particular bit. It is actually working on the data as a whole, right? But then if you take the data, convert it into bits, pure bits, ones and zeros, and then try to manipulate the data by using the bits, then such operations are generally called as logical operations. Since again we are manipulating the bits and so the data, the logical operations will also form a part of the data manipulation instructions. Therefore, every computer will generally provide some instructions in order to handle these bits. Sometimes they are also called as bit twiddling operations. Twiddling means changing. So let's see what are the available operations, and then we can go ahead with that. I'll show you how they are used. So the basic operations which any computer will provide is logical ANDing and logical ORing. So we know logical AND and logical OR like this. So logical AND and logical OR are simple. So if I have 0 1 1 0 1 1 0 0, if you talk about logical AND and logical OR, this is 0 0 1 0, logical OR is 1 1 1 0, right? So these are the logical AND and logical OR. So these two operations are going to be provided in all the computers, and using these we can actually implement all the other types of operations. Okay, let's see here. Now we have one more logical operation called as clear. So clear is generally done at the register level, and we know that every register is made of flip-flops. Flip-flops have already a control called as clear input, right? So whenever we have, if you look at this SR flip-flop or JK flip-flop, if you give the input as 0, the output is going to be 0. Therefore the flip-flops are going to have within themselves this clear option. Therefore we need not separately implement it. It is already implemented. So clear is nothing but changing all the bits to 0. If you apply clear input to a register, it means that all the bits of the register have to be changed to 0. And the next one is complement. So complement means we know that taking the ones complement is nothing but complement. So how to implement the complementation operation is by using exclusive OR. I'll come to that point. Okay, so we have one more operation called as exclusive OR. It is not the basic operation, but it is provided by most of the computers. So what is exclusive OR is, we know this. You can also think of it as modulo 2 sum, which means add these two bits and then take the remainder when you divide with 2. So what is modulo 2 sum of this? 1. Modulo 2 sum of this 1 0 0. Right. So for these inputs I have shown you all the three operations. Now assume that these three are provided. Now using these three we can actually manipulate any part of the data. For example, if we have the data like this 0 0 1 1 0 0 0 1, something like this, and now we want to make this particular part as all ones. Only this part I want to fix them to all ones. Then what I can do is, for the remaining positions I can take 0, and for those positions I can apply 1, and then I can apply logical OR operation between these two operands. Then what happens? Automatically all these three will be set to 1. In case if you want to mask these bits means if you want to make them as zeros and leaving the other bits as it is, then what I can do is I can use 1 1 1, and in this place I can use 0 0, and I can use 1 1, and I can take these two operands and apply logical AND. If I apply logical AND, 0 ANDed with any of this is going to be 0. Therefore using such manipulations, using these basic operations AND and OR, what I can do is I can take data and manipulate any part of it or the entire thing, right? If you want to set everything to 0, for example, if you don't have clear, if you want to set everything to 0, then you can use AND, and you can AND everything with 0, and you are going to get the result as all zeros, right? Or load it with 0. Similarly, you can even complement the entire data. I'm talking about one's complement. You cannot do the complementation of the entire data or a part of it using exclusive OR. If I use exclusive OR, right, if I want to complement this part, if I want to once complement it, which means this part has to become 0, these two parts have to become 1 and 1. If I want to do that, then I can apply exclusive OR. How can I apply exclusive OR is, I can take zeros in wherever I don't want to manipulate, and wherever I want to complement I can take ones, and wherever I don't want to change I can take zeros, and between these two operands if I apply exclusive OR, then this particular part is going to be complemented. So what I mean to say is, using these basic operations we can modify the entire data at the bit level, or some bits at the bit level, or a group of bits at the bit level, right? So all these are actually related to bit manipulations. That is why they are called as logical operations. And moreover, one other reason why they are called as logical operations is, when we go to the bit level, each bit will be taken as a boolean value, which means if the bit is 0 we can consider it as false, if the bit is 1 we can consider it as true. And this will be especially useful when we are doing some condition checking using the flags. A flag is a single bit. So we have something called as a flag. A flag is 1 bit data, and based on the value of a flag we can perform various operations. Okay. And next one is clear carry. Carry is a flag, as you remember. Carry is a flag which will be generated when we are talking about addition. And after addition, if you get a carry, if you want to clear it before performing the next addition, then you can apply this input. Clear input, clear carry means whatever value is there, you have to make it as 0. That is the meaning of it. And since carry is a flag which is nothing but 1 bit, which is implemented using flip-flop, we already have an input to the flip-flop to make it 0. That is about the implementation part. And set carry is nothing but we can purposefully make the value of the carry as 1. So why do we do this? I have already shown you that in order to perform subtraction, it is nothing but, if you want to perform a minus b, it is nothing but a plus 2's complement of b, right? Then how do we implement it? A plus 1's complement of b plus 1. Where does that 1 come from? From the carry, right? So it was discussed already when I was discussing about the implementation of addition or adder, implementation of adder in digital. You please watch the digital videos once. Okay. And next one is complement carry. So whatever value is present here we can complement it. Some of the instructions will need that. And enable interrupt and disable interrupt. So the interrupts we'll again discuss about it at detail, right? For now don't get into what the interrupt is, but then understand that for this particular operation there is a special bit designated or a flag designated which is called as interrupt flag. Enabling interrupt means making it as 1, and disabling interrupt means making it as 0. So some of the instructions or some of the operations programs will need to enable or disable the interrupt before they go ahead. Then using these instructions we can do that. So whether this control is given to user or not, that is secondary, but then there are instructions, either operating system can use it, or if given the liberty, users can use it, end users can use it, but the functionality has to be provided by every computer. Almost every computer is providing that functionality. Okay, so whatever it is, all these operations which we discussed are actually applied at the bit level. The data is converted into bits and we operate on the bits. That is why they are called as logical operations. Since we are manipulating it, they form a part of the data manipulation operations. So first one is arithmetic, next one is logic, and next one is shift. We shall see shift next.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.